Good morning, good afternoon, or good evening, depending on where you are in the world. And thank you for joining this learning experience brought to you by Mend. My name is Cody, and welcome back to Techstrong Learning. Before we dive into things, I have just a couple of notes I'd like to review with everyone. First off, we are recording our session today. So if you happen to miss any of our discussion, if you'd like to watch at a later point in time, or of course, if you'd like to share with the rest of your team, we will be sending out the recording via email shortly after we conclude this live session today. So keep an eye on your inbox for that recording. Now, if you'd like to get engaged, there are a couple of ways to do so. The first option is to use the chat tab on the right side of your screen. So when you see that chat tab, I'd like you to let us know from where in the world you are joining us from today. Now, if you have specific questions, we do want you to direct those to the Q&A tab on the right side of that chat section. And we do have some time set aside for Q&A at the end, so be sure to send those questions in as you think of them. Additionally, if you jump to that handout section, there are a couple of resources there for you, so feel free to grab those throughout our program before we close out. And we will be selecting 2 of our most engaged attendees to win a $50 Amazon gift card. So ways to become eligible are to send in your chats, questions, and of course, we have our post-webinar survey. So today we'll be discussing transformative benefits of automated dependency updates for your applications. I'm joined today by Reese Arkins, VP of Product Management at Mend.io. And we are also joined by Justin Clarebert, Senior Product Manager at Mend. So Reese, Justin, thank you guys so much for joining us today. I'm going to pitch the microphone on over to you guys and let you dive right in.
Thanks, Cody.
Thanks very much.
All right, so I'm first up with the bio. I didn't put it in the chat. I didn't want to spoil the very important first slide here. I am in Sweden, coming through from very cold, snowy Sweden today. My name is Reese. I am Australian, not native Swedish, of course. And I am the creator of Renovate Bot, which we'll talk a little bit about today. And I describe myself as an accidental open source and security professional. I found myself in this line of work unintentionally, but enjoying it a lot these days. So, Justin.
Thanks, Reese. Over here, whoops, sorry, I've got this. My name's Justin Clarebert. I'm also an Australian, currently residing in the Netherlands. And I've been in the IT industry since last century and have had my turn around the major tech circuit, working with Google and Microsoft and Amazon and Booking.com, to name a few. Yeah, but now I also find myself loving the open source security. So that's us. Let's move forward. But Reese and I both really head up the Renovate squad over in Mend. And so we're here today to share with you a lot of experience and knowledge about what we think about dependency updates. So let's take a look at the agenda for today. So first, we're going to work over the topic about dependencies and updating dependencies, why it's important to update dependencies, and really cover over the pros and cons in that. And then we're going to move on to really what's at the core of this seminar, which is automating dependency updates and how transformative that can become. Then we'll talk about some specifics about how to handle it once you do have automated dependency updates, including avoiding breaking changes. And then there's a bunch of other advanced topics that we'll talk through as we get toward the end. So without further ado, let's get into the first topic and discuss software dependencies, and specifically why it's important to update them. So first, let's talk about what we mean by software dependencies. Software companies, any company, a bank, a grocery store that is writing software, they write their own software and they often rely on external coding dependencies. Nobody writes everything, so quite a lot of the code, up to 80% or more of it, can be included with external dependencies. This is software packages that are written by other people and hosted in other places. And often these packages, they get improved over time, and it's really good to be able to pick up the latest in these dependencies. Let's talk about why you would want to do that, because of course there's the classic engineering phrase, which is if it ain't broke, don't fix it. So if you've got an application that's happily running along with a dependency that may have been updated, but you've got an old version of it, why would you bother updating that at all? If you do go to update it, it's going to take you time. There's risks involved, downtime, deployment risks, not to mention you're not building features. So you'd want to be worth it if you're going to invest your time and create risk in updating dependencies. So why would we want to do it? We would declare that an out-of-date dependency is technical debt. And even though the code itself hasn't changed since it was first put in, what has changed is likely that potentially security vulnerabilities have been discovered, or that it's working on aging, deprecated platforms. And all of these things do contribute to something that will need to be fixed eventually, hence the technical debt of an aging dependency. The next slide, we really run through some very specifics. But before I go over to that, I'm going to hand over to Reese for comment at this point.
Thanks, Justin. I was about to interrupt you otherwise. I wanted to say that actually something that is a little bit new, let's say last 5 years, if you're a real kind of leading edge, but less for many, is this concept of dependencies really expands beyond just pure software. So software dependencies, we're talking NPM modules, we're talking about Maven dependencies and things like that. Things you download from Ruby gems and so on. But anything that is external these days is generally treated like a dependency, including a lot of DevOps stuff. So as an example, the base images that you build your applications from is a concept of a dependency. So if you're building it from Alpine, from Ubuntu or something like that, that's a base, that's a dependency. And yeah, it can get outdated as well. And similarly, those images that you build or that you use can then go into Kubernetes manifests, into Helm charts or other forms of GitOps. So in general, if it's a third party that you depend on, it's a dependency, and ideally your dependencies should be versioned, ideally immutably, but otherwise that's version them, keep them updated. That's the general concept of using third-party software.
And there's a note on the slides worth dwelling on, which is the fact that these dependencies are the tools of software developers. It's what provides the APIs, the methods, the calls, or the base images that software developers rely on to achieve their magic. So as you're updating, getting newer, greater software dependencies, then you're getting better tools to work with, and your software is then better as a result. So I guess it's in the camp that people really do want it often, even though it might take time. You get better things as a result.
Yeah, I'll add one more thing there, Justin, and that is although at Mend we are a security company primarily, that's not the real main focus today. We'll talk about which aspects are security related and which bit not. But I did want to differentiate between kind of two forms of updates. Okay, so you have the update where there's newer versions of say React or something like that, and you want to update, or Spring Boot. We're talking sort of voluntary proactive updates mostly, and the benefits of that. Not so much the updates you may be familiar with where somebody suddenly says, oh, geez, we have a vulnerability. It needs to be updated now. That's kind of the, urgent, critical, forced security updates. So, I'll use an example. If your IT person kind of popped by your desk and said, you wouldn't want one of those new M3 MacBooks to upgrade to, would you? You'd say, yes, please, faster, better, I'll do it. But at the same time, if that same person popped up to your desk and said, drop everything now, close your MacBook lid, I'm taking it, and I'm going to give you back, an M3 soon. That is like kind of less welcome by most people, that urgent. So what we're talking about is that taking control and staying reasonably up to date with dependencies in a proactive manner.
Sounds good, except when Log4j comes through, and then seriously, take your laptop away, deal with it now.
Yeah, close it.
Yeah. Okay, let's look at some specific examples. So maybe I'm going to ping these out at you, Reese. Let's talk these through. If you're missing out on bug fixes, so what's good about updating dependencies? All right, if we're not going to update dependencies, you're not going to get the bug fixes, right?
Yeah, exactly. So, we are standing on the shoulders of giants. We're using open source software in particular, sometimes, closed source proprietary libraries occasionally. And in both those cases, generally, bugs are found and fixed. And in fact, it was a bug in Google's Firebase library, which triggered me to create the very first ever kind of renovate script. We were accidentally running a version that had a bug that was affecting about 5% of users. It took us a while, to realize users were affected. It took us even longer to realize that actually it's not our fault. There's a version fixing it. And all of that could have been avoided if we'd just been proactively adopting bug fixes, in particular. So just because you're not aware of a bug in a package or library you use doesn't mean that it's not there. Doesn't mean it's not affecting your users, and definitely doesn't mean you shouldn't update to it.
Good one. And I'll talk about the next one, which is that similarly to that, as developers put out fixes in their bugs, they often put out new features. It can be new APIs, new methods, or even just new underlying algorithms in the methods that are improvements. Sometimes there is new features, and that's less important for the act of keeping yourself safe and reducing technical debt, but it can be useful if they bring out features that are powerful and can improve the way you write your code. And moving forward more to the next one, which is that the software that it might be using could be relying on other software that is deprecated or soon to be no longer available. And if you don't update the dependencies, you might very quickly find yourself unable to deploy your software onto modern infrastructure because it's running on newer technology that has deprecated some of the libraries that your old dependencies are relying on.
Yeah, example of that one, Justin, is where, a library might find, a newer, better way of doing things. So they say, hey, we've got a new API for doing this. We're going to support the old API, for the next 2 major releases or something, like don't panic. But we recommend you use the new API going forward. Now, if you haven't updated to that new version, you don't know about the new function call, the new option, the new API, and you'll just keep accumulating that technical debt that you need to rewrite later, writing for the old unknowingly kind of deprecated, functions or options. So this can often catch people out where they really dig themselves into a hole and increase the amount of code they need to rewrite.
That's right. Now, the next one touches on the security aspect of updating dependencies. So apart from the benefits of just getting better software, even if you don't notice a specific change to the software, to its APIs or its workings, in many cases, it might have fixed a vulnerability. Or to put it another way, if you don't update your dependency, the chance of vulnerabilities in those dependencies being discovered increases, and it increases exponentially over the first 30 days as well. So the more you leave those old dependencies there, there's an unknown risk that's constantly increasing, that somebody's going to find some way to breach and use a flaw in that code to get into your systems.
Yeah, we had one of our customers recently was telling us that they did a calculation in the Java ecosystem. So they looked at their actual dependencies across thousands of projects, and according to their calculations, 90% of the vulnerabilities they had in their large enterprise would be solved by simply being on the latest version. Fixes exist. So they view it that proactively updating dependencies. Even if you never paid attention to your security alerts, not that we recommend that, but if you were completely oblivious to security alerts and you just had a process for staying reasonably up to date, 90% of total vulnerabilities, as a ballpark figure, would be automatically resolved by that updating.
And interestingly, you're talking about the known vulnerabilities, and a person can clear themselves of all known vulnerabilities, yet still they might have vulnerable code we just don't know about. It just hasn't been discovered yet. So you can't even look at a zero score and say, I'm great, I'm all good, because by next week, somebody might have discovered something. So it's always good to stay on top of it. And on that point, Reece, talk to us about the model in which people typically withhold information about known vulnerabilities for that reason.
Yeah, so this is this kind of concept of having a disclosure period. So the idea, and it's well followed these days, is that if people find a vulnerability in software, open source or otherwise, they will disclose it discreetly, allowing it to be fixed, allowing new versions to be published, and potentially even for very important downstream users to be notified, like if any major libraries are users. And the idea of this is that by the time you hear about it, by the time you get alerted to it, a fix already exists. You know, you're not left with this 0-day kind of concept.
There we go. And I guess that's similar to the last point, that you're increasing the risk and stress of vulnerabilities. So those vulnerabilities that we do know about, well, they just become more and more exposed. Yeah,
so, you know, good example here. Let's say you are reasonably up to date with your dependencies. You may be, you know, one feature release behind of a certain package. If that package gets a vulnerability, you know, alert tomorrow, you'll have one feature release worth of, you know, code change and release notes to review and say, it looks fine, let's test this and this, and then merge. If instead you were like 2 years behind, you know, you might even be major releases behind. So that's where we say it's the risk and the stress of vulnerabilities. The risk is two ways. You've either got the risk of slowness, you know, hey, we can't merge this yet, there's so many changes, or we need to do code changes, you know, that's a risk it takes longer. Alternatively, the other risk is you might just, you know, put it live, but then the risk is that you've kind of got a lot of change code that's untested. So if you are far behind on dependencies, you know, you are increasing the risk and your stress and everyone else's stress when they occur.
I see. I think you might be hitting on to the big important point we're about to make in the next section about the fact that the more often you keep your dependencies up to date, the less work you need to do when eventually you really must update in a stressful time. So on that point, I think I should move forward out of this section and we'll start talking about automating dependency updates. And as I was just saying now, we're on to the key point, which Reese was just talking about now, which is that updating dependencies is like going to the dentist. If you only do it every few years, it's going to hurt. And that's really what it's all about. And so automating dependencies can help reduce that, would we say, debt lag where between the latest and where you're at. Before I launch in, Reese, got any precursor comments to make about the topic of updating automated dependencies before I go into the details?
I was just going to say our dentist joke is based somewhat on another kind of saying, which is you know, a little more widely used. You know, people say if something hurts, do it more often, right? You know, and that includes things like exercise and the dentist and things like that. So it's a good thing with dependencies. Like if people think it like is difficult or hurts to update dependencies, it's because they're not doing it often enough. They're doing too much in one go. Just like, you know, you don't go for a 5K jog except for on the 1st of January every year or something. It's going to hurt.
Mm-hmm. That's right. So now let's talk about the process of updating and also why it's good to automate it. Because let's say we do want to keep our dependencies updated or our terraforms, our base images. How do we go about doing it? So I guess going back 10 years ago, before Renovate was around, the way people would do it would be to manually, occasionally, search around at various different websites and vendors of software, looking to see whether there'd been any updates and whether or not they should take them, download them themselves, add them into their project, and then I guess try to test them and jam them in. You can see just how I described it, that's not the sort of thing teams can be doing frequently. Even if they are, it would be very difficult to get around to visit all the websites of all the dependencies. It's the sort of thing that basically it just won't get done because unless maybe there's one dependency you can keep a check on, but then it's going to require other dependencies that it needs to work on. So the idea of manually updating dependencies, well, even though it is probably one of the more commonly used methods in most software companies, it's not a very good one. And it's likely to lead to updates happening less frequently or not at all. So then we go over to something like a semi-automated updates. And I guess that's where, say, you might have a company server and someone DevOps group or security is keeping your local server updated, and your software is polling frequently to pull perhaps in a repo. And so every time you build, you're getting the most
Another
recent.
way is, people running something like npm outdated or something like that, to kind of get like a semi-automated way of finding updates. npm outdated says, oh, you have 27 outdated, and you kind of go, okay, that one. This is sort of reduces the time compared to fully manually doing it.
Right. But I suppose what it's lacking then, and what makes a fully automated system, is a couple of things. One, that it will happen without you telling it to. So we're talking about some scheduling. And also that it might create the pull request for you. It's one thing to know there's an update, but it's another thing to do the coding, find out where the change has to happen, submit it to the repos. So that's where full automation can really help, because if a developer comes to their desk and sees that there's a pull request waiting for them and they can just press a button, or better still, have configured that under some circumstances they will be automatically merged, then we're really stepping forward into a fully automated dependency update system. So the question is, how frequently should we be updating? I mean, all well and good to say that we should have an automated system and be getting the latest all the time, but do we always want the latest? And do we want the latest as soon as it came out? This is quite a fun topic. So we might just banter about this for a little while. What do you think, Reese? Oh, sorry, I can't hear you. So maybe.
Sorry, I muted myself so I wouldn't echo to you. Thanks for that. Yeah, I just wanted to say, by the way, we're starting to get some questions coming in, there's one talking about the risk of bugs or vulnerabilities in new versions. I just wanted to say I've seen your question, and we are going to get to that. So don't worry. If you have any other questions, please put them in the Q&A as we go. All right, so here we're talking about how frequently to update, so always up to date, this is like immediately up to date. Now, this can sometimes be the compulsion of people, especially when you discover automation. People sometimes can be like, in our open source repo, where we build Renovate, they'll be like, oh, I saw that there was a new version of, React put out like an hour ago, and I haven't got a pull request yet. Like, where is it, kind of thing, right? So sometimes people really want them, but there is sort of two real main cases where you want sort of updates to be immediately. Okay. So the first of all is where there is a specific new version, of a package, hopefully one you kind of trust, where you're waiting on a particular bug fix or feature. And then that makes a lot of sense. You might even be watching the repo and you say, great, it's out. I want to try it now. Right? So that's one time where you might want to have things immediately. The other category, which has become increasingly useful, is when you have internal packages. So not so much on the open source side now, but we talked about the Docker base images before, for example. So sometimes companies build an internal base image. So they might build it off, Ubuntu or Alpine, and then they will potentially harden it, or they'll add logging tools by default and observability. And then they wish for other people to use it. So let's say that there is a new update of a company base image. The people who built that would really want that to go out to all of the downstream projects kind of as soon as possible. Occasionally even have a developer that is like publishing an artifact, like an npm module or a Maven package, and they themselves want to use that downstream in another project. So these are some cases where kind of taking updates immediately, is a good idea. For the rest of them, I think that the vague kind of term of reasonably up to date is a good way to look at it. We talked about the benefits before, obviously first, intentionally, because you understand the benefits. Like, well, if I'm not up to date, I'll have challenges with X, Y, Z, and things like that. So being reasonably up to date, means that you are reasonably well prepared if you have a vulnerability alert, like I said, one feature release behind or something like that. And it's a pretty good kind of posture to take in software. So by reasonably up to date, I would say something between 1 week to 1 month. That type of range would be what I'd call reasonably up to date. One of the reasons to wait a week is because of those potential bugs, especially if it's a feature release, right? So sometimes, things are rewritten or new features are added.
You don't want to be the first person to guinea pig the new release, do you?
Yeah, exactly. So, if you're really waiting for that feature, and you know how to test it, go ahead, or if it's your feature. But for the people who don't have to have it right away, it is often good to wait for that feature to see if, any bugs are reported, new bugs are out. Another topic, is malicious packages. And we've done whole webinars on that, so we can't go into detail there. But what I'll say is that when malicious packages are like caught, and there's a lot of private companies, and not just the registries, like private companies, including ourselves, who scan for malicious content. Those are generally found within minutes, hours, or at most days. And we're not saying that, the security world catches everything, but when we do catch it, it's usually, within that first week. So that's also why 1 week can be a useful time to do it. Now, there are valid reasons why, updating, kind of weekly, every 2 weeks or something like that, every sprint is not possible. So in this case, still periodically is better than nothing. Quarterly, at least annually, setting yourself some rules, a little bit is better than nothing.
Yeah, that's a good point, because of course there's a trade-off in every business about how much time people can spend doing, well, maintenance in a way, versus productive features. And sometimes it's important for a business to decide to allow maintenance to go by the wayside because there's an important business target that they have to reach, and they're prepared to catch up with technical debt later. And if the business is spent every day updating dependencies, they might never get anywhere. So it's important for the business to be able to weigh that up. But of course, this is where it helps that the easier it is to automate this process, the easier it is to make it happen more frequently, right?
Yeah, so it is a lot easier to take, 1 or 2 small changes, than to take, 27 small to medium changes over a year or something like that. That's the type of dependency updating people are, often stressed out by.
Well, now that's interesting you should say that. I guess that's not what I had in mind, but it's a good point, is that the way that we group and filter and deliver the updates can make a big difference as to how easy it is for developers to accept them.
Yeah.
That might be something.
So we've got another, question came in about saying how dependencies sometimes can cause a break, for example, because of other dependencies. So we've got a bit talking about breaking changes coming up. Don't worry, Justin, don't panic. Okay. Jumping ahead. But I did want to talk about this mention of because of other dependencies, because we hadn't specifically covered that. And so I thought that's a good one. And you mentioned grouping. So one of the things that you can do, to minimize the chances that, an update to dependency A, breaks dependency B. The most common reason for that is that actually both A and B need to be updated like together. There is some form of codependency. So that is definitely quite mature these days. You of course can do like ad hoc groupings where you set grouping rules where you know that 2 dependencies together, it might be like ESLint and TSLint or something. You say, let's just always update them at the same time because they often break if they're separate. Alternatively, the other, good default to have is to always update monorepos at the same time. Yeah. So for example, AWS's SDKs, they've split that these days into a lot of different ones, like S3 and things like that. You definitely want to update those together. Like whatever you're using, if there is a new version 2.6.19, you should, update them all to 2.6.19 at the same time. It not just saves yourself time, less clicks, less pull requests, but it also means that there's less chance that they'll have some type of kind of codependency causing them to break. So yeah, to stop the update of one dependency being a problem for another dependency, grouping is definitely the answer to that.
So a bit of a challenge though, Reese, as to how a software company will know what all the various groupings should be. This is where the community have contributed with Renovate. Can you tell us a bit about community contributions into Renovate, even though it's jumping a little bit ahead? We're on the topic.
Yeah, sure. So, Renovate is open source, as we've said. And so part of that open source is a series of community contributions to groupings, both default groupings as well as recommended groupings. And so what that does is allow people who've I guess in most cases, they've been stung once and realized, I need to update these together. And they then contribute a rule to Renovate so that not only for themselves, but for all other users of Renovate in future, they can benefit from that same grouping rule so that when there is, dependencies, if that's a thing, that they'll be updated together.
Right. Well, that's pretty important, isn't it? And there's dozens of these curated groups that the community have contributed over the years, isn't there?
Yeah, yeah. And we're also working on ways to automatically detect those, So for example, these days, we have logs, a log message that says, hey, two different, dependencies were from the same source repo. Maybe they should be updated together and things like that. So we also help to try and prompt people, and we're working on ways to actually allow people to opt into automatic grouping based on the source repository.
Good. So I feel that we've done a great job of addressing the question about how do we handle updates when one requires another. And so that's all on that topic. So we might move forward a little bit now. So still on automating dependencies and why it's so important, let's talk about here automation. So we know it's important to update dependencies and that automation can help that process. I guess the theory is that if it doesn't become automated, it gets forgotten. Too difficult it is to try to arrange to manually do something. We get busy, things get in the way. So if there's not a process, sometimes things just get left by the wayside.
Yeah, also, being realistic, any project that doesn't have, either KPIs based on it being done manually or automation just won't do it. That's just being realistic.
That's right. And of course, we're going to have some human error involved. If somebody is manually doing it, you might forget. You might do 29 out of 30. There's just too much error for human error. I mean, too much allowance there.
Yeah. I mean, you can forget to commit a log file or update the log file, or there's any number of reasons, ways which you can accidentally mess up.
Certainly not going to get to benefit from some of the community contributed curation, having to keep a list of all the different things you need to update at the same time. What a pain. So hence automation is faster and more responsive to updates. I guess, what do we mean by more responsive to updates there?
Yeah, so for example, in Renovate's default settings, including in the free app that we host, we often set a cache time of 15 minutes. And what that means is that, within 15 minutes of the previous kind of lookup being completed, we'll try again and check whether it's changed or not. And so that means that, for example, a user of an NPM package could get pull requests within 15 minutes if they are configured that way. It also means not necessarily that you get the pull request. We've got, great concepts like, dependency dashboard, where you can get visibility into the updates without necessarily getting the pull request itself. You can choose which ones to take. So it can be useful also just to know there are updates, even if you're not applying them yet.
Got it. And in a responsive manner. We're not waiting a month for the annual Gazette to come out and tell us. The automation will mean that potentially within 15 minutes, if there's a new version available.
Yeah.
That's right. And then we come to the key part, which is the developer time is too valuable to be spent doing these sorts of chores manually, which is probably why it won't get done if it has to be done manually. So there are better things developers can be doing rather than updating dependencies.
Exactly. No developer's time is worth so little that they should just be doing stuff manually that, a machine, can do in essentially zero time.
Well, what do they say? Why send a human to do what a robot can do?
Yeah, it's a Matrix quote. Never send a human to do a machine's job.
Right. And here we go. So speaking of machines that do the job, we might as well put a plug in here for Renovate Bot, which is...
so we've been talking about this one. So Renovate or Renovate Bot is an open source tool that Justin and I and our colleagues maintain, mostly for free. It's freely available. Over 1 billion Docker pulls, and it's probably, let's say, it's the tool with the most wide support for platforms. GitHub, GitLab, Bitbucket, Azure DevOps, AWS Code Commit, Gitty, even Gerrit, for those who've heard of that, was added quite recently by a contributor. So it's we call it a kind of universal update tool where we aim to support all platforms and all ecosystems of dependencies, both software and DevOps.
And I'll talk a little bit about where this fits into the automation of dependency updates. There's the open source tool, Renovate, is effectively a CLI, which users can use to run over their repositories. They can schedule it themselves. They can put it in a pipeline. And when triggered, somewhat manually or through a pipeline or a scheduling tool, it will do the process of automatically looking through the repo to see what dependencies you have, automatically searching known repository version information, and if it detects any updates, automatically creating pull requests if configured to do so, or at least updating the dashboard to show you this. So this part is automated and allows people to just come and just see the results straight away.
Yep.
But where the automation stops is that it doesn't by itself have scheduling power, webhooks for responsiveness. Yeah, mostly that's it, isn't it? It's not self-scheduling, and it doesn't respond to webhooks when people make changes to the code repository. Yeah, and we got a question that came in, so it's a good time to answer that one. It said, use of package managers is required. Yes, it's basically based on package files, such as Maven, Gradle, NPM, and so on. But the key question was, how does it hook in? How does it automate it? Does it hook directly into the repository? Need to be run part of CI? So the answer to that is kind of yes and no, because you can run it multiple ways. So yes, you can run it in CI. But you also can run it, for example, as a stateful Kubernetes application. You cannot run it at all yourself on github.com and soon some other platforms. We at Mend host the free version of it. So you just go to github.com, apps, renovate, install, pick which repos you want, and then you don't actually have to run anything. And in fact, it hooks into the repo much more tighter as a GitHub app than you can do in like a pipeline. Because like a pipeline task can't be listening for webhooks. It can't be running forever and things like that. Whereas those are things we can achieve as an app. And I'm going to expand on that. I guess what we're saying is that there is the executable CLI, which is available, open source community. Everyone can use it however they like. But we at Mend have built some automated scheduling systems, and one of them we host for free for the public and run on github.com. We also make available a self-hosted version so that people can run it themselves, the Renovate Community Edition and the premium product Renovate Enterprise Edition, which has unlimited scaling. So those are other ways. So those are basically the three Renovate systems for building the scheduling and fully automating the process of dependency updates. So that's enough about automating dependency updates. Let's move forward a little bit and maybe start talking about some advanced topics. Yeah, so the next one is about avoiding breaking changes. We're actually accumulating a few questions in the Q&A on that one. So I hope you don't mind. We held back a little bit on that one. So let's cover the slides as we wrote them, and then we'll go back through the Q&A just to see if there's anything that we missed. Great. I invite you to take over on this slide here, Reese. Okay. So, yeah, I mean, people often, this is sort of really like a kind of software thing, right? We talk about things breaking change. Right. And so let's define different ways in which you can be broken by an update. So like the obvious one is what I'll call regression errors. So for those who aren't familiar with that term, a regression error is essentially something used to work, but now it doesn't. It regressed. It got worse. So that's the most obvious one. So someone might be, building a feature or maybe even trying to fix something else. And when they did that, they broke something related, something, in the same library. So, you're relying on it to send emails and now it doesn't send emails, for example, in your use case. Now, often usually these regression errors are not like, it doesn't send emails. It's often like kind of narrow, but when libraries are popular enough, there can be tens, hundreds or thousands of projects affected by that. A much more subtle kind of breaking change to you as the end developer and user. It's still kind of like a break to you, but this is not because like something used to work and now it doesn't. I call this a change in behavior. And so technically everything still works, but it might be working in a way which impacts your downstream software or users. So maybe they thought that they are improving the functionality, changing the functionality. This is much better, but it's a way that impacts you or impacts directly to your users. So this one's a lot more subtle because it may not even be clear that the
say open source developer wants to actually fix that, because they don't consider it sort of a bug necessarily. They did it deliberately, but just didn't think of the consequences. Now, the third one is probably the rarest, but it's kind of cute to talk about. And this is like a bug fix can break things. So, and I got a simple example for this. So in rare cases, there can be like your downstream software is relying on a library or an API behaving the way it does, even if in a way it's like a little bit buggy. And one day someone might decide to change that. And we have a problem. So real simple example, let's say there's like an API or an SDK, and it has been returning null as a result. And someone looks at it and says, no, the docs say it should be returning 0. It's the count should be 0, not null. And they say, yeah, look at that. That's obviously a bug. Let me fix that. And so they fix it, 4-character fix or something, 0 instead of null. The problem is, if you're a user of that library and you were relying on it null, you had to check if answer equals null, not if answer equals 0, but if answer equals null. So that's an example of like an actual bug fix that can still kind of break you. So these are breaking changes. And I haven't covered here, of course, the ones that like in a major release, we can call it a breaking change, right? But it's like documented. It says, hey, we've renamed this or something. People are worried about these forms of breaking changes. Like it should keep working, but it doesn't.
That last one is interesting, isn't it? The where a business has deliberately written software around a known bug. I do recall from previous employment when we had to deal with a new version of a database that was being released, and this new version of the database fixed a known bug. But we had been living with that known bug for so long, we had absolutely written code around it, and we had to put off upgrading the database until we had worked out all the places where we could change to fix the fixes.
Yeah. I mean, it might be an API that's meant to return paginated data, but it just returns like 1,000 in one go instead of 100 per page. And you wrote the code there. You didn't know exactly that was a bug, and then one day they return it in pages, and you only get 100 results.
So how do we know? How can we know, Reese, what's going to be impacted in the changes?
So, slides are often, we can't fit everything we want to fit. So the topic of this slide is not best practice, just to be clear. This is like, how would you, as an individual or even as a team, how would you on your own try to assess the breaking change risk? Okay, so you can read, and by the way, these are still good things to do, just to be clear. You can read the release notes. So, hey, we've put a new version, and it might say, fixed bug in the whatever SDK, and you can say, oh, I'm using that SDK. Let me have a look. It might say complete rewrite of, function X should be the same.
And that should send some alarms off.
I'm using X. So, so reading the release notes, still good practice to do, but let's be realistic. Not everyone's got time to read all of those.
Or even to find it. I'll point out.
True. Yes, that's true. I mean, if you're not using a tool like Renovate that includes release notes with every update, you got to go off and find those.
Yeah, I'm not sure everybody knows this, but when pull requests are delivered by Renovate, it usually includes information about the updates, including the change logs and release notes. So that's handy. But what about the next one, Reese? Okay, so you really want to know what the code's doing. Go look at the code.
And now we go really in the category of things people don't have time for, and that's reading the source code. So, for example, for some ecosystems, you of course can go off to say GitHub where it's built and have a look at the changes. Sometimes we're able to include like a direct link, between the two commits, sort of give you a semi-automated way to do it. But again, realistically, very few people, have the time to do that. And we're not saying like you're a bad developer if you don't do that. Just, Justin, you said earlier, I mean, your job is to, build a taxi app or build a rental app, a hotel booking app, where you used to work, not to be spending all your time, reading source code of, someone else's projects.
Which I suppose is why the next one on the list is probably the fallback and maybe the most reliable, most commonly used way of determining if there's a breaking change is run it.
Yeah,
run it on your application.
And again, this is recommended no matter what we're going to say in the next slide about, an even better thing to do. But you should run the test. But here I also wanted to include a disclaimer. What we're really talking about here is specifically detecting, regression errors, accidental, undocumented breaking changes in third-party libraries. And the challenge is that not only do most projects not have perfect tests, but even when you have great tests, even when you test 100%, code coverage of your repo, that doesn't mean you're achieving 100% code coverage, of your libraries, right? It's not your job to test your libraries as well. And for example, if it is we talked before about, I gave the example just randomly about doesn't send email anymore, but it's an accidental great example. Because if you are testing, a web app, and one of the things that is meant to do is to send an email, after sign up, you're probably not going to send actual real emails every time you run tests locally or on CI. You're probably going to use some form of library or stubbing that, mimics that library.
So you won't pick up whether it's actually sending that.
Exactly. So, even with great own tests, you can't be sure. But these are sort of like building blocks, which makes it good for you to assess. And so I think, I know what the next slide is. So I'm going to segue into it, Justin, just by saying, I want to give an example here. If we were, sitting down to like a team dinner or something like that, and we ordered some wine, and the waiter pours, a little bit of red wine into your glass, Justin, because you're the boss or whatever, and says, how is that? Now, you got many years of experience, as you told us. You can swish it around and sip it, and probably, I'm guessing, you would have a good level of confidence that it's okay. But would you bet your life on it? Definitely not. Would you bet $100 on it? I don't even know, right? I mean, on your own, you can be confident. Well, if there was something wrong with it, I'd probably know it, right? But you wouldn't be sure. Okay. Yeah. So, but if on the other hand, that waiter poured a little bit into 8 people's glasses, and everybody said, yeah, it tastes good to me. And then I said to you, Justin, would you like to bet $100 that this wine is good? You'd probably take the bet, because what that is crowd confidence.
I see.
There we go.
So crowdsourced data to the rescue, hey?
You want to take this one? I've been talking too much.
Before we do, I just want to go back and just on the topic of whether or not how to test, just to hit back in on this one. Most people will unit test their application functionality, and they won't capture the full functionality of the embedded dependencies. But a really solid quality system would have functional tests or end-to-end tests that cover the entire functionality. But it's a goal that nobody can ever really achieve. To be able to capture 100% of functionality, people do best bet at that point. But that's probably the only place where you'll pick up changes in the dependencies is if you've got good automated functional end-to-end dependencies.
Yeah, true end-to-end functional testing, of course.
But it's painful and time-consuming to try to functionally test everything, which is why we rely on our unit tests, which skip over dependency testing. Right. Meanwhile, back to the fun stuff of crowdsourced data. So yeah, let's talk about this. So what we do at Mend is we are able to capture data from, both public and private repos about which of our Renovate updates we're able to pass tests successfully when run through. We can use that information to help build up our own algorithm to determine whether or not this glass of red wine has been well accepted by everybody else at the table, because we're getting these results. We know the age of a version, and age is very important because sometimes if it's too new, as we've discussed, it's a risk. But if you're holding on to a dependency that's really old, that's a risk too. But if you're going to take in a dependency that's lived long enough, chances are it's been through a lot of scrutiny and it gets safer. And then, of course, there's adoption about how many people are taking this one up, and the pass rates, and all that can be combined in a little algorithm that we can use to generate a merge confidence score. So you can just look at that and get some feeling about what we recommend. Of course, it's not going to solve everything. It can't tell you for sure it'll work, but it can help you judge which dependencies you might want to take today and which ones you might sit on for a little bit longer.
Yeah. So, I mean, ironically, using the analogy before about wine, age of wine, it doesn't map. That's the one thing that doesn't map, but I'll try to kind of compare here. So the passing you see here, that's an example of test passing. So the Mend Renovate app is installed into nearly 1 million repos. And what that means is that for most popular packages, they get tested by thousands of projects. And that gives us a pretty good idea. So it's not 8 people sitting at a table, it's thousands. So that, you know, that little sip and does it taste corked, you know, that is kind of like your tests, right? And we can see that 99%, you know, thought it was good. And there's always going to be like a little bit of noise, just to be clear, you know, like, you know, false negatives, I guess we'll call it.
Well, that's because the developers themselves write bad tests and they get included in our results, right?
GitHub Actions goes down or something like that, right? So that's your passing point. The next one is adoption. You see here it's in orange kind of, because it's indicating, you know, 5% isn't huge, obviously, it's not 100%. But keep in mind that you rarely ever get like even above 50% adoption of any one release, you know, and that's fine, because if releases come out every week, and we were saying the gold standard is up to 30 days, you're never going to get everybody aligned on one release. But adoption you could think of as to say, oh, well, 5% of all the tables finished that bottle of wine. They've like, it's done. You know, they've taken it, they've adopted it, they've deployed it. And again, you know, so adoption is a powerful kind of indicator. Now, the other one, it's not shown here, but a very strong indicator is whether any people rolled back. You know, that's like sending the wine back. You know, if more than one table sends if one sends it back, it's, you know, concerning. If multiple do, you probably would go out to every table and say, hey, there might be a problem here. Don't drink it, you know.
Right.
So, yeah. So what we do at Mend is gather this aggregate data. And then in the end, it's the one on the right, which is most important, which is confidence. Because in the end, what we're trying to do, you know, for you as the end user and developer is just to be able to say, yeah, look, you tell me what to do. If it passed my test and you tell me it's high, I'm good. Let's go. I don't want to think about it. I don't want to read source code. So
I realize that we're 50 minutes in and we have one slide to go over. So
plenty of questions. So let's, in fact, let's see where we want to do the questions or the advanced topics. Justin, what do you reckon?
Let's have a look at the questions.
Yeah.
Yeah. And I'll preview some of the talking points that we might throw around in the next minute.
So ironically, the first point we have here is also the last, kind of like the last question that we just had pop up on us. So shall I answer it?
Yeah, let's answer it in 1 minute or less.
Yeah. Okay. For big scale repositories, self-hosted Renovate, are there options in order to decrease execution times? I'll go through like just some examples. So one of those is that if you use an app-based approach where you're listening to webhooks, it means you don't have to schedule repositories so frequently. You know, because you think developers have an expectation that if I tick a box or something, I should at least in an hour or something see a result. Whereas if you do webhooks, you can prioritize those ones and then deprioritize, like lower prioritize scheduled jobs. So you could even run like, you know, every 6, 12, 24 hours on a repo. So what that does is take pressure off. The other thing you can do is some advanced features on caching. So you can do package caching, like the result lookup caching. You can extend your cache. So if you say, I'm happy to have like 1 hour stale results instead of 15 minutes, you can do that. You can also cache repository data. So repeat runs on the same repository, reuse existing results. So
from my own local testing, that makes dramatic improvements. Like you can take a 30-second run down to 4 seconds if you're caching the repository data.
All right. So I'm going to mark that one as answered. And we've got a question here kind of asking to compare to competitors. But like, I mean, obviously I'm going to give you like a pretty biased kind of one there. So I'm going to
do it. Tell us in a minute.
Well, all I'll say is that the main difference between competitors is most competitors are focused on security fixes only rather than proactive updating. So that's like a dentist who is, you know, very good at drilling, right? And that's their job. Hey, you know, let your teeth go bad, bring them to me. I'll drill them out. I'll charge you thousands. You know, we believe in kind of, you know, regular checkups and cleaning, you know, being proactive, keeping those dependencies up to date. So that's
one other main difference is that there's not many other products out there that will create a pull request. A lot of products will say, here, you've got a bunch of problems. Now go deal with it. Whereas Renovate creates pull requests.
Okay, that's the perfect segue into the next question. I'm going from the bottom here. If dependencies are fully automated, reading the release notes will be too late to prevent applications from breaking. What can be done? So the answer to that is, generally, the default behavior is Renovate does not automatically merge the updates. It creates you a pull request for you to approve. So generally speaking, you're going to get a pull request with release notes and that data we showed you, those lovely, badges. So you actually make the decision. Now, On that note, we have a lot of great features for what we call auto merge, but we advise that you use that selectively, such as for, internal packages or packages older, than a month or something like that, just to avoid that chance of, being caught by a bug or a malicious package.
And of course, the Renovate Enterprise product offers the ability to auto merge based on the merge confidence of a package, which is a neat feature.
Yeah. Okay. And we covered another one on testing there. There's a question on when you're talking about updating dependencies, is that for direct or transitive dependencies? Generally speaking, it's for direct. However, asterisk, when it comes to, and the reason to not do transitive by default is that would be a massive load. If you think you're getting a pull request every time any dependency out of your 1,000 has an update, you'd just be flooded. You'd hate it. You'd uninstall it. However, 2 times where transitive is useful. First of all, we've done this since almost day one, is you can do a scheduled lock file refresh. And what that will do is actually update all transitive dependencies at once, for example, weekly. A second time where you can do transitive or indirect dependencies is for very specific cases for security vulnerabilities, because sometimes you do actually need just to very pinpoint fix that. And because that is hopefully low volume, it's an acceptable, exception to that rule that, you don't want to update all of your transitive dependencies. All right. And I think, well, I was going to say we've got time for one more, but I think we answered that one. The risk of bugs or vulnerabilities that might be introduced. I guess we talked about bugs.
We did. Yeah, that's
right. One. That's a good, because it's a valid concern, even though I'm going to kind of, minimize it here. Because you've got old software vulnerabilities. And if you say, what's the point of updating though? Because there's probably going to be some new vulnerabilities anyway. I may as well just do nothing. Frankly, it's a bit of a fallacy. There's a very big, kind of order of magnitude. Like if you were to take the ecosystem and say, what's the average number of dependencies in the latest version? It's going to be like 0.01 or something, like 1%.
Vulnerabilities, you mean?
Or vulnerabilities. 0.1 vulnerabilities in the latest version. If you were to say, what's the number of vulnerabilities, 10 versions back, it's going to be much, much higher. All right. So just on average, it's not, to say, well, it's like, again, it's like,
like taking a vaccine, perhaps.
Or like, let's not get into that, Justin. I'll say the people who say, oh, you're just as much risk crossing the road or something like that. I mean, yeah, there's a risk in crossing a road, but the order of magnitude, is. So
I'm going to take over now and just say we did discuss these other 2 topics here: first-party dependencies versus third-party. That's like whether or not your application's reaching out for NPM or whether you've got some Terraform or even libraries that your company has got. And so Renovate is a tool that can actually fetch them both. Risk strategy, we did talk about the best strategy, like how many days to wait. And so we've covered that topic as well, which means
we say thank you.
We do.
We share some links, but of course, if you search for Mend Renovate, you'll find it. We welcome back Cody just to finish out the hour. And as he asked, please take a second to fill out our survey. Assuming the survey is asking you if this webinar was any good, please say yes.
Yeah, and thank you very much to everyone for listening in.
Thank you for the questions.
Absolutely. Well, Reese and Justin, thank you all so much for joining us today on Techstrong Learning. It's such a pleasure having you guys on here with us. So we really appreciate your time and your expertise. So once again, thank you both.
Pleasure. Thanks for having us.
Thanks, Cody.
So before I release our audience, just a couple final reminders. We have been recording our webinar today, so you will be receiving that recording via email here shortly. You can also find it living on the Security Boulevard website. That's securityboulevard.com/webinars. I'd like to thank Mend for sponsoring our program today. And we will also be reaching out to 2 of our most engaged attendees today to win a $50 Amazon gift card. So it is not too late to fill out that post-webinar survey and become eligible. So once again, thank you to Justin and Reese and our new 3rd co-moderator, or co-speaker we have on the panel with us. Everyone have a great rest of your day, and we hope to see you at a future Techstrong Learning Experience. Bye, guys.
Bye-bye.